discuss an exercise on deduction. Here it is. Three persons, Alice, Bob, and Cauchy, made the following statements. Alice claims, I am a mathematician. Bob claims, I am not a mathematician. And Cauchy claims, Alice and Bob are not both mathematicians. We assume furthermore that exactly one person is lying, and at least one of them is indeed a mathematician. We are asked to determine how many mathematicians there are among these three people, and identify who are mathematicians. Alright, you can see that in this exercise we're given a lot of conditions, and we know that sometimes when we're given too many conditions, we often have trouble figuring out what is the best point to start with. Nevertheless, the first step should always be transforming these concrete statements into formal statements with the help of propositional symbols as well as logical connectives. For example, let us denote by A, B, C the three statements that Alice is a mathematician, Bob is a mathematician, and Cauchy is a mathematician, respectively. From there, we see what Alice has claimed is precisely the statement A, what Bob has claimed is precisely not B, and what Cauchy has claimed is precisely not A and B. In the following, I will discuss two approaches. The first one is on the semantic side, using truth table. Notice that the statements made by Alice, Bob, and Cauchy are either one of the atomic propositions A, B, C itself, or a compound statement whose truth value is completely determined by those for the atomic propositions A, B, and C. Thus, it is straightforward to list the entire truth table. Now, let us observe the truth table. Also, if a person has lied, then the statement he or she has made should be false. Now, the assumption that exactly one person is lying indicates that one of the three statements they have made should be false, and the other two should be true. And looking into the truth table, we notice that only the last two rows are possible candidates. Now, taking into account the last condition that at least one of them is a mathematician, we see that A, B, C cannot be all false. Thus, the last row is eliminated, and we see the only possibility is that Cauchy being the only mathematician among the three persons. Next, let us try to solve the same exercise using the rules of inference, and we do this by discussing different cases. First, let us assume that Bob lies, while the others do not. Thus, we assume not B. The double negation cancels, leaving us with B. Moreover, since Alice does not lie, A can be considered as our premise as well. From A and B, we derive their conjunction. Now, Cauchy does not lie neither, which means that not A and B is also given as premise. Thus, A and B, as well as its negation, together leads to a contradiction. We conclude that if not B, then we have a contradiction. As a result, we derive not B. In other words, we concluded that Bob does not lie. Next, let us assume that Cauchy lies while the others do not. This means we should assume not A and B. Again, from this double negation, we derive A and B, which in turn implies B by the rule of simplification. However, since Bob does not lie, not B is also our premise. Again, from B and not B, we have reached a contradiction. Since the double negation of A and B results a contradiction, we conclude that not A and B is true. In other words, Cauchy does not lie neither. Now that neither Bob nor Cauchy lies, the only person who lies is Alice. As a result, Alice is not a mathematician, Bob is not a mathematician neither. However, since there should be at least one mathematician, we don't have any other choice but to conclude that Cauchy is the only mathematician. In this way, using the rules of inferences, we have rediscovered the same conclusion which is previously achieved through truth tables.